To understand the 2026 energy pivot, you have to look under the hood of how we move. A traditional internal combustion vehicle is already a marvel of electrical engineering, containing roughly 20 kilograms of copper for its starter, alternator, and basic wiring. It's a stable, well-understood requirement, but the electric revolution is not an incremental change. It's a total reimagining. Enter the electric vehicle. A single EV requires nearly 80 kilograms of copper, 4 times the amount of its combustion counterpart. Most of that extra copper is hidden in the battery. Miles of thin copper foil are used as the current collector for the anode. Then there is the motor. High-performance electric motors rely on dense copper windings to create the powerful magnetic fields that drive the wheels. The more efficient the motor, the more high-purity copper it demands. There is simply no substitute for its conductivity and durability. And the demand doesn't stop at the car. Every high-speed charger and every substation upgrade requires massive amounts of the red metal. The charging infrastructure alone will require millions of tons of copper by the end of the decade. When you multiply that 80 kilogram requirement by the millions of EVs planned for 2026, the numbers become staggering. We are looking at a projected copper shortage that could stall the very transition it's meant to enable. New mines take 15 years to reach production. We are trying to solve a 2026 problem with a 2040 supply timeline. The physical reality of the Earth is pushing back against our digital ambitions. With production concentrated in Chile, Peru, and the DRC, the supply chain is fragile and fraught with geopolitical tension. Copper is the new oil. Nations are now competing to secure the metal that will define the next century of power. While some suggest aluminum as a substitute, it lacks the conductivity needed for high-performance EV systems. Copper is the non-negotiable king. To build the electric future, we must embrace the red metal. There is no plan B. This leads to greenflation. As copper prices rise, the cost of the energy transition goes up, potentially making EVs less accessible. Material scarcity is the ultimate brake on our sustainable ambitions. We must also face the cost of extraction. Mining for a green future requires energy, water, and social responsibility. The energy transition is not just a digital shift. It is a heavy industrial undertaking. In the race to 2026, copper is the gatekeeper. Secure the conductor, and you secure the future. Ignore the geology, and the pivot will stall. We must decide now, secure the conductor or risk a future that remains offline. Navigating this pivot requires more than just capital. It requires the character to face these physical limits with dignity and responsibility. The decisions we make today about copper will define the landscape of the next decade. If you found this investigation into the EV copper gap valuable, please like and subscribe for more in-depth documentaries. Thank you for watching. Stay curious, stay informed. We'll see you in the next investigation.